All right. Good evening, everyone. Welcome back to another week, another productive week. I hope it's going to be a productive one. I trust that everyone here had a productive week. You're alive and you're well. You're not sick. No one died. I'm assuming no one died. So if you're here, that means you have a purpose and you have a chance to correct past mistakes. You know, you have a chance to do better than what you did yesterday, last week, last month, and last year. So, welcome, everyone. I'm very happy to be here. This is one of my favorite classes to teach, especially online, because I love the online platform. I feel like it's the best learning hub. That's just in my opinion. But again, you guys gonna get 100% um commitment from me, and I just hope that you guys can reciprocate the same. All right. All right. So just a quick update as it relates to how we're going to be proceeding with the teaching. I think I may have explained this to you, but it may have flew over your head. So I'm just gonna tap back into the plans of how I teach. Now, usually I kickstart off by spending a week or two, kind of just feeling out where you guys are at with the fundamentals, testing some areas, and then um, every week, right, I do one fundamental topic and one core topic. All right, core topic meaning the major topics in CSEC. So starting tonight, right? Starting tonight, we'll be doing a core topic tonight. So on Monday nights, we are going to do a core topic, right? A core CXC topic, and on Wednesdays we will pick up on our fundamentals. All right. So meaning that wherever we stop on a Monday night, we don't return or continue on that topic until the following Monday. Similarly, on Wednesday, wherever we stop on a Wednesday, we do not pick up on that topic and continue until the following Wednesday. All right. And why I do this is for a few reasons. One, to keep me entertained because I don't want to have to teach the same topics 3 times in one day. All right. That's for my benefit. And two, we get a chance to dibble and dabble. Right. We don't just make the class monotonous, thinking that, okay, the whole exam is going to be based on fundamentals of math. So you have to understand there's a relationship between the core topics and the fundamentals of math. So that's what the aim of what we're trying to do. All right, so hopefully you guys can monitor yourself and be disciplined and understand that on Mondays we do one core topic and on Wednesdays we do fundamentals. Once the fundamental topics are finished, we'll replace fundamentals on Wednesdays with another core topic. Similarly, whenever we finish our core topic on a Monday, we'll replace it with another core topic, and it goes on like that. So basically, each week we're going to be doing two different topics that are correlated, but two different topics each week. All right. So hopefully you guys understand that. You can just give me a thumbs up in the chat. Just give me a thumbs up in the chat if you understand that process. Okay. All right, Chelsea. All right, just give me a quick thumbs up so you make sure you guys understand the plans that we're going forward. Okay. All right, lovely. Really, really nice. All right, fantastic. Good. So, with that said, then we are going to kickstart tonight with a core topic because in my other class, what I do is that tonight I taught them fundamentals. So you are doing a core topic. That means when you're doing fundamentals, they are doing a core topic. So that means every night I have something new I'm going to teach. So it makes me excited. It keeps the excitement up for me to teach, right? And I'm not bored, okay, when I'm teaching. All right, good. Please ensure also, guys, that when you're entering the classroom, your name on Zoom should be the name that is on the class pass or on your register. For example, I just had a Samsung person just entered the class. Please ensure that your name is as that, because when I check the group at 7:45, I will remove persons if I do not know your name. Okay, there are persons here that will send the links to their friends for them to join the class, and we can't have persons paying for the session whilst other persons are getting it for free. It is only out of due respect for everybody why we do this, okay? All right, lovely. So with that said, we are off and all the announcements are made. I am loading some topics for your SBA as well. So that's not yet posted. As soon as it is posted, as soon as that is posted, I will let you know in Google Classroom or in the chat. And assuming that everyone got a chance to either watch the videos of the recording, all right, if you didn't get a chance, then that's okay. It's always there for you to watch. And also, you would have seen in Google Classroom, I loaded 15 practice questions for you. I loaded 15 practice questions for you to practice. Remember, submitting them is not mandatory. If you would like to do them and you'd like to get a review on them to see how you've done, then okay. But I'm not forcing you to submit them. All right. It's just if you want to submit them, it's just that I've set a deadline for them. That means after Wednesday, if you do not submit it on Google Classroom, then I will not be able to facilitate giving you a review because I have other things that I'm going to be focusing on. So if you want to try them and get a review to see how much out of 38 you got, then you can submit them on the Classroom. If not, or you just want to keep your answers to yourself, then that's fine as well. All right, it's your option. Shaniqua, good night, Mr. Peter. Are you going over the paper? What paper are you talking about, Shaniqua? Oh, as in the practice paper. I'm going to be posting the solutions in Google Classroom. All right. I'm also going to be doing a video on it as well. Yeah, man. I'm going to be doing a video on it. Every practice paper I give you, I do a video on it because I can't use the class time to go through practice questions. All right. It's going to defeat the purpose of getting through these 15 major topics in CXC. So I do videos on those stuff. All right. Yeah, man. No problem. Go ahead and submit it on Wednesday. All right. So with that said, ladies and gentlemen, let's kickstart tonight's class. You can head up on your book, ladies and gentlemen, that we are going to be starting the topic of mensuration. I will do just that, Akila, in the group. Okay, I'll do that. If you have not gotten the link to the Google Classroom, you just have to DM in the group and then I will respond to you. If you're not able to access it, I'll reset the code. Okay. All right. So we're going to go ahead then and start. Looking for my whiteboard. I don't know where it's gone. Let me see if I can find it. Hold on, give me a sec, guys. So I need to. I don't know where it's gone. Okay, let me just type whiteboard here. Okay, there we go. All right, lovely. All right, lovely. All right, so I can't respond to anybody in the group who's sending me a message at the moment. Let me just check the group one last time to make sure that everybody's admitted in the class. Good. All right, so I'm not letting anybody in now because it's way too late for that. All right, guys. So tonight we are going to be talking about mensuration, right? Or better yet, let's just call it measurement. Let's just call it measurement for conversational purposes so that everybody can understand what we're on. Okay. I don't want to use that whiteboard. I want to use a different one. All right, ladies and gentlemen, we are going to kickstart it today. All right. So our topic is going to be the topic of measurement. Okay. We are going to be looking at a core topic. So the core topic is measurement. And essentially, what we are going to be discussing, so the objectives of this topic, the objectives are, we're going to be discussing mainly concepts surrounding surrounding areas of two-dimensional shapes, 2D shapes, and volumes. Oh, I cannot spell. I'm so sorry. Volumes of solids. Solids, I'm going to put in bracket another word for solid that you might be familiar with, prisms. Okay, so essentially then what we're looking at is the core topic is measurement, and the objective at the end. At the end, we should be able to understand comprehensively the concepts surrounding the areas of 2D shapes and the volumes of solids and prisms, right? Now, in addition to this, we're going to be looking at something known as the perimeter of shapes. So for everything that we do, we're going to attach the concept of perimeter of shapes. All right, we're going to look at the meaning of perimeter, how to find the perimeter of different shapes. Later on, we're going to look at volume of the prisms. All right. So let's just save this document right here and put it to the side here. All right, lovely. All right, good. So we are going to be focusing for the first 4 classes, I think. We're going to be focusing on the areas of the shapes, because for you to have an understanding of how to find volumes of solids or volumes of prisms, you're going to need the information on areas of the 2-dimensional shapes. So essentially then we're going to be starting off with what is the definition of what is an area. What is an area? Or what is area, I should say. What is area? All right, so again, I'm not going to do any verbal conversations. It's just going to give you the information. What is area? Well, essentially then we can safely say that area is a measure of the surface. Sorry, its area is a measure of the total surface covered by a 2-dimensional shape. 2-dimensional shape. All right. So what is area? Area is a measure of the total surface covered by a 2-dimensional shape. Right. It's a total surface covered. Okay. So that's what, by a formal definition of what is an area. But there is a keyword in that definition that you guys might not be familiar with, and that is going to be, in fact, 2-dimensional shapes. So when we talk about 2-dimensional shapes, we're looking then at so let's look at the types of 2D shapes. So sorry guys. They call you teammate, that's why. So I'm in the class, but I'm going and class is being recorded. I'm gonna let you. I do apologize for that, guys. I think there's a student that is in the room. Remember, guys, it's very important that you try to come early, so we don't have this happening. Okay. All right. So essentially, then, what is an area? Area is a measure of the total surface covered by a 2-dimensional shape. All right. So let's look at the different types of 2-dimensional shapes. All right. So let's list them out. 1. We're gonna start off with a square. 2. We're gonna look at the rectangle. 3. We're going to look at the circle. 4. we're looking at the triangles. Notice I've pluralized the word triangle because there is going to be more than one. When you have one square, one rectangle, one circle, you we have more than one types of triangles. 5. We're going to look at the trapezium. 6, we're going to look at the parallelogram. 'I don't think I can spell this word, I've always had problems with this word. Okay, there we go. All right, so square, rectangle, circle, triangles, trapezium, parallelograms. I think that's just about it. I know you guys might be asking about the rhombus and the kite. Remember that we're not teaching the entire concept surrounding area or two-dimensional shapes. So we're focusing on the ones that most likely would come on your external exam. All right, so the square, the rectangle, the circle, the triangle, the trapezium, and the parallelogram. I don't think I left out any. I don't think so. I'm thinking off the top of my head, I don't think that I've left out any. All right. So the kite and the rhombus would make up the 8, but we're just looking at the 6, the 6 main ones that potentially might come on the exam. All right. Now we're going to be looking at the area, right? Oh, I need to mention as well, guys, that area is measured in squared units. And what do I mean by that? It means that if the dimension of the shape is centimeter, then what you're going to find is that the area is going to be cm squared. So normally we use a thing like this. You write cm to the power of 2. I think on this, I think there's a symbol cm squared. So I think you do something like cm, and then we do to the power of 2. All right, that's how I have to write it on the computer here. All right, so area is measured in squared units. That is cm cubed. Cm squared, pardon me, m squared. So if the length is measured in meters and you're finding the area, it's going to be meters squared. If it's measured in centimeter, when you're finding the area, it's going to be centimeters squared or squared centimeters. Everybody speaks differently. All right, the British say squared centimeters, the Americans say squared centimeter squared. All right, either ways, it's the same difference in my opinion. All right. I don't think there's any wrong or right way to say it, but all right, everybody's different. All right, so these are the shapes, ladies and gentlemen. Let's save this. Let's bring this information here. All right, let's put this information over here. Can I put it right here? All right, lovely. So that's basically what we're looking at, ladies and gentlemen. All right, now with this information that we have, it's very important, right? Just like if you go to university or if you go to a college or we are going to constantly remind you of the basics. And so even though for some persons here, they might have already have an understanding of what the shape looks like and all that stuff, we're still going to have to carry some of the persons with us as we go through this journey. Okay, so we're going to be drawing the shapes, and we're going to be looking at the different properties of the shapes as well as attach some formulas. So essentially, guys, this is your introduction to your first set of mathematical formulas. Some of them CXC helps you with, CSEC helps you with them, right? So the ones that CXC helps you with, I'll tell you, so you don't have to pack up your brain trying to study the formula. But the ones that CXC don't send come on the formula sheet, you might have to definitely go ahead and study them, okay? All right, so essentially then, let's just grab a square. Okay, lovely. Look at that. But this is a text box. Let me get a shape. There should be like a shape thing here. Okay, give me a second, guys. There should be like some shape stuff here. All right, so this might be it. All right, so essentially then what we're looking at is a square. All right, so this is like an example of a square. Let's just zoom this out a little bit since you have that information already. It's not supposed to be like that in a what. All right, here we go. All right, ladies and gentlemen. Lovely. So this that you're looking at on screen here is an example of a square. All right, perfect square. All right, so here we go. That's a square. All right. And so when it comes to a square, very importantly, what makes a square is the fact that the square has 4 equal sides. So we're going to use a red marker here and we're going to mark it. All right. So this side and that side and that side and that side is they're all sides are equal. Okay. So that's what makes a square. And along with the square, we have a right angle in the corner here and one right angle here in the corner and here and here. So each corner measures exactly 90 degrees. We're not talking about degrees though. We're just talking about length and area. But we have to mention that what makes a square is the fact that it has 4 equal sides and it also has 4 right angles. Let's just jot that down right here. A square has 4 equal sides and 4 equal sides and 4 90-degree. I don't know where it's gone. Okay, 490. Let's write the word instead. So 4 90-degree angle. 90-degree angle. All right. So let's just drop this information right here. Lovely. So a square has 4 equal sides and 4 90-degree angle. And that's what makes a square a square. Now, because the square has 4 equal sides, we do not differentiate between the lengths, right? So we just simply say that this side is L and we say that this side is L, right? Unlike the rectangle where we have to say length and width, for the square, we don't really differentiate between the length and the width. We still simply say one side is L and the other side is L. All right, or if you want to call it W and W or A and A or P and P, we just normally use L because L represents the letter L is symbolic to the word length. All right, so we'll just say L. All right, for those who think it's an E, that's my way of writing an L. So please pay attention to my verbiage as I speak. All right, this is a L. This is an L. It's not an E. That's my way of writing L. All right, now let's look at our first formula, right? Our first formula then is that area, oops, pardon me, that's not a very good A. Area is equal to length multiplied by length. All right, that's the area of a square. Area is equal to length multiplied by length. Now we can simplify this worded formula into something more mathematical, such as A we can say that A all right, here we go. So we can say that A is equal to L squared. All right, let's put that in a little box right here. All right, let's put that in a little box right there. All right, so that's your first formula, guys. Area is equal to L squared. Sir, where did you get the square from? It's 2 lengths. So we just, instead of saying length times length, we'll just merge them together and just say length to the power of 2. All right, sir, can I say length times length? Because I don't think I'm going to remember length squared. Okay, you have students like that. As simple as it may be, they'll say they can't remember it. But yeah, I mean, you can say area is equal to length times length. I don't recommend you doing that, but I do strongly recommend you use area is equal to length squared. Later on, you'll understand why. So for now, area is equal to length squared. All right. And attached to this now, we're going to use a different color here, right? And we're going to look at perimeter. So we're going to use green for perimeter. Whenever we're talking about perimeter, we'll use green. And whenever we're talking about the area of the shape, we'll use red, okay? So perimeter. Now, what is perimeter? I think we just need to bring up a text box here. All right, so perimeter is a measure of the distance around the edge, around the edge of the shape, of whatever shape it may be. All right, so we don't just want to say it is a, around a square, because it's around the actual shape. Just drop that right here. Hopefully if it's not too crowded, then you guys can understand that. Gotcha right there. Okay, perfect. So, all right, here we go. Good. So let's drop that right there. All right, so perimeter is a measure of the distance around the edge of the shape. All right, so basically what we're looking at is just basically adding up all the sides going around. All right, so we're just adding up all the sides. So what we mean by that then is that if you're looking at that blue square there, we're looking at adding that side to that side to that side to that side, adding up all the sides, right? Now, it's very evident that if all the sides are the same by logical deduction, right, by logical reasoning, we can just simply say that the perimeter is equal to L plus L plus L plus L. But that kind of tedious to write down L plus L plus L plus L. It's kind of annoying, right? So just simply just write down 4 multiplied by L. All right? And let's put that quick little box around that here. Make sure everybody's comfortable with that. Lovely. Beautiful. Beautiful. All right, so those are your two formulas for the area of, that is the formulas that are attached to the square. The area is equal to length times width, and the perimeter is equal to 4 times L. Now, you can common sense out the thing when you're doing an actual exam. You don't necessarily have to write down A is equal to L squared and P is equal to 4L. You can just simply just do your calculation and show it. But for this topic, I do strongly recommend, one of my rules for this class, well, not the rules, one of my recommendations for this class, right? And it's why I recommend it so much is that we use the principle in other topics to come, is always write down your formula. You'll hear me say that all the time. Always write down your formula. It doesn't matter how simple the question may be. Sometimes the question comes in reverse. Sometimes the question ask you for the obvious. All right, so sometimes I can give you the area and say find the length, or I can give you the length and ask you to find the area or the perimeter. So it just comes back down to the question itself. Yes. All right. All right, so give me some thumbs up in the chat, guys. Let me see if you guys are with me so far. Everybody's okay. All right, this is good. Everybody's thumbs up is going up. All right, Stacy, you're good as well. All right, lovely, beautiful. All right, there's more persons in the class. I'm not sure what is going on with the thumbs up icon. Not sure why everybody's not using it, but the thumbs up means that you're good to go or we can move forward. Thumbs down meaning that I'm not clear, I have no idea what you're saying. So you're not being forced to use it, but it does really help me to understand without having to use the microphone. All right, lovely. Oh, did I just see a message? Oh no, I didn't see a message. Okay, all right, lovely. All right, so back to my whiteboard then, lovely. So with that said then, let us do an example of an application question then, right? Because it doesn't make sense if I give you the formula and you don't have an example to work with. So let's grab a different color square then. Why is that? It's supposed to have like a shape. All right, okay. So let's here. All right, so let's zoom up here. Let's grab this shape, bring it down here. It's a perfect example of a rectangle square. Okay, and then I'm gonna attach a length, a numerical value to one of the lengths. So I'm gonna just say that this side is 6.9 centimeter. Okay, we're gonna call that. I like using decimals because I feel like when they use whole numbers, people think it easy and just limit themselves to that. So I'm gonna call this side here 6.7 centimeter. 6.7 centimeter. I don't need to put 6.7 on the other side. It's a square. I will know that all sides are equal. So if I put one side to be 6.7, it logically means that all sides are 6.7. So from this information, then I can ask you then to go ahead and find the area, right? So I'm going to use red. As I said earlier, once we find the area, we're going to use red. So then formula then would have been area is equal to length multiplied by length, all right, or L squared. So therefore that would be equal to 6.7 multiplied by 6.7. And if you go on your calculator, can someone tell me what the response is through the microphone? I don't have access to my calc. I might have to grab it. Go ahead, guys. Tell me what it is. How much is it?
44.89.
I didn't get that. I'm so sorry. Go ahead.
44.89.
44.89. And remember that it has to be centimeters squared or squared centimeters, right? I take off a mark if you leave off my squared centimeters, okay? If you leave off that squared centimeter, sir, why are you so harsh? It's not me. I was punished. You're going to be punished too. You leave off that square centimeters, it is incorrect. Okay? The unit of measurement must be attached to the answer. All right? All right? All right. And if you're going to your calculator, guys, and you press 6.7 and press the power button that we discussed in our last class and press 2, you get the same answer as well. So everybody have a different way of working it out. All right. So let's move on then to finding the perimeter. Perimeter is going to be equal to 4 multiplied by L. All right. 4 multiplied by L. Let me just use the regular L I was using earlier, so don't throw you off L. So it would be 4 multiplied by 6.7. All right, and I have my calculator in hand, so you guys have to move faster than me. I'm getting 26.8. Can someone confirm that answer? 26.8 squared centimeters.
26.8 centimeters.
Right. Well, okay, good. I'm glad you mentioned that because the perimeter doesn't have a squared unit on it. Okay, because the perimeter is distance. So area is the only thing that has squared units. The perimeter, you just write the centimeter because that's distance, okay?
Okay.
All right, pretty much that's pretty much how you do the question, okay? That's pretty much what they would ask you at this very level, all right? Now, of course, I can write the question in such a way that potentially for some person, they might make a mistake, all right? The example I use in my class is I tell students all the time that if you're able to press on the accelerator and allow the car to move forward, then you should be able to change the gear and press on the accelerator for the car to move backwards. So if a question can be calculated going forward, then you should be able to get a question and be able to calculate it going backwards as well. All right? So here we go. Please write this. Oh, sorry, I have a monitor, so I can go ahead and type it for you. So here's a worded question, something that we don't get a chance to do a lot, but I make it a priority to involve this type in my teaching. Okay, so here's a worded question, no diagram, but these are just words. Okay, so given that the area of a square, given that the area of a square is 54 square centimeters, so I'm going to write cm. I'm going to use my power symbol 2, so that means square centimeters. Okay, when you see that, that means it's the area, right? So given that the area of a square is 54 square centimeters, I'm going to put a comma here. Calculate the length of one of its sides. A typical question that students make a mistake on, right? It's very simple, but yeah, Here we go. So there's a question. All right, so given that the area of a square is 54 square centimeters, we are to calculate the length of one of its sides. All right, so we're going to grab that question. We're going to put it right here. Let's zoom it out here. All right, let's move it down here. Lovely. All right, so this is the actual question then. So given that the area of a square is 54 square centimeters, calculate the length of one of its sides. All right. Now, when you get questions like this, maybe it's simple, and for some person, they don't need to do all this extra stuff that I'm going to show them. They may be able to just run through it. Thumbs up to you, right? For my students, all of you are my students, but for students, I do recommend that always draw a picture. A picture tells 1,000 words. So when I go here and I draw this shape here, this square. All right, that's perfect. Is that a perfect square? Doesn't look too good. Let's try it again. I know you guys get the idea, but I just try to keep my thing as neat as I possibly can. All right, so let's draw a square here. All right, that looks more like a rectangle. Let's try it one more time. All right, I'm going to work with that one. It's not perfect, but I guess you get the idea. So I'm drawing a picture, right? I'm converting the words into a picture. All right, so what information is given to me here is that they're telling me here that the area is 54. So where is the 54? A lot of students, and I've seen this over and over, students put the 54 on the edge right here. All right, they're just not reading with understanding, okay? So it is inside here, ladies and gentlemen, that is the 54. 54 is inside here. So all of inside here, so measures 54, not the edge. So one of the things that beats students badly, right, believe it or not, is the English language. The subject you guys love the most is the one that beats you the worst, right? The comprehension part of the question. So it is inside that measures 54. What we are looking for is the length. We're looking for what side multiplies to give us the 54. That's what we're looking for. What side, what number multiplies by itself to give us 54? All right, so in order for us to figure that out, ladies and gentlemen, we're going to use that rule that I talked about earlier. What is the rule? Always write down your formula. And so your formula for the area of a square is that area is equal to, this time I'm sure I'm going to use L squared. Okay? I'm sure I'm going to use L squared. I don't want to use L times L. All right? So area is equal to length squared. All right? All right, so area is equal to length squared. Now, here's how you set this up, guys. You're going to write the only number that you have under the respective letter. Since they told us that the area is 54, it naturally means that the 54 goes under the letter A. And then you're going to equate that to L squared, because you don't know what L squared is. Now, here's where you're going to learn something quite new. I'm going to use a different color here. I'm going to use let's use orange. No, orange is let's use purple, right? So here's where you're going to learn something now, that in order for you to remove a power, all right? So in order for you to remove a power, doesn't matter what the power is, to remove a power, we use the corresponding root. Corresponding root. I've written this in a text form, so that this looks so untidy. Let's do that again. So, in order to remove a power from a variable, we use the corresponding root. right, I'm going to drop that information right here. And drop it right here. Good, perfect. That's much better, much more tidier. So in order to remove a power from a variable, we use the corresponding root. That is therefore then the square root of 54 will give us the value of L. So go on your calculator. I'm grabbing my calculator here, and it is telling me that the square root of 54 is 7.348, some long number. So I'm going to round it up and say 7.3. So my L here, 7.3, would have been equal to length. So therefore, what I'm saying then, essentially what this is saying is that 7.3 multiplied by 7.3 will be approximately equal to 54. If you reverse and say 7.3 times 7.3, you realize that you get 53.29, but when you're basically rounding it up, you get approximately 54. All right, you get approximately 54. So so L wouldn't necessarily be equal to 7.3. L would be approximately equal to 7.3. Let me just write that symbol better. So it would be approximately equal to 7.3. Better yet, 7.4. Okay? All right, so that is how you find the area. Attached to that, now we're going to go ahead and find the length. Sorry, find the perimeter. All right, so perimeter then. So P is going to be equal to 4L. So therefore then, we could not have found the perimeter if we never find the length. So we have to use that 54 to find the length, and then now we can then use the length now to find the perimeter. So therefore perimeter is equal to 4 multiplied by the approximate answer of 7.3. Therefore the perimeter is approximately equal to 7.3 times 4. I'm getting 29.2. 29.2 centimeter. All right. So, sir, why haven't you written on the square on none of the answers? Because I wasn't finding area at all. I was given the area, but I was finding length, okay, and perimeter. So you have to bear these things in mind. They're very simple, but it's highly underrated, guys. Very simple concept, but it's highly underrated because of the English and the comprehension behind the question. So this is the question where you reverse it to go backwards, all right? And with time and we do practice questions, or you see these things, you're going to get a hang of it over time. But this is essentially just an overview of what can happen to you on an assessment or on an exam, all right? All right, so if everybody's up and running with me, let me see some thumbs up or thumbs down. Everybody's good to go? All right, looks like everybody's happy so far. Fantastic. Lovely. Beautiful. All right, Miss Carrie, I'll see you in the last part there. All right, lovely. Good. So let's move on then now to the rectangle. Remember, this is just a basic overview, right? You're not really going to get into the CSEC topics yet, but this is the tool you need. So essentially, I gave you the hammer and the nail, and then essentially you just have to learn how to use the hammer and the nail to drive it into the surface, and that's going to come over time. But we need the tools. So I'm going to give you another tool again now. So we're going to grab a rectangle here. Oh, sorry. Nope, that is incorrect. I might have to turn this into a rectangle. Yes, go ahead. I'm listening.
The root part kind of confused me, to be honest.
Come again?
What you did to get the 7.3, that part kind of confused me.
No problem. Let me just grab my calculator because maybe you have a calculator in your possession?
No, I wasn't using a calculator. I was just following along.
And right, so that's the reason why maybe you got lost. So I'm going to grab my calculator on screen here. Should you get access to a calculator, what you're looking for is this button right here. Sorry, I'm pressing it too much time. So it is essentially then that the square root, so see I press it there, that one with the 2 is that symbol there. That's the square root symbol. I press 54 and then I press equal. That's how I got the 7.348. Okay. All right, good to go?
Yeah, got you. Thank you.
You're welcome. All right. Let's get back to this here. Okay, so now we have this rectangle, which is a more elongated shape, right? It's more, I guess it's the same thing as a square, but it's just longer, which means that you have a long side and you have a short side, essentially. It's loading. I don't know why it's taking so long. Give me a second, guys. I think it's the wrong one. I think I may have clicked on the wrong board. Okay, this might be the one. I don't know. I don't know why it's not loading the right one. All right, so it would be, which one is this then? It must be this one, because this would have been 1958. It had to be this one. All right, yeah, this is the one. All right, lovely. All right, so now what we're looking at here is a more elongated form of the square. All right, I'm trying to zoom it up so that we can see that image alone. Right, good. So essentially, this is called a rectangle.
Sir, we're not seeing the whiteboard.
You're not seeing anybody else having that problem? Anybody else?
You're unable to see it.
Not seeing
Yes,
it.
yes.
Yes,
I'm not
sir.
seeing it either.
Okay. All right, sorry, my screen share went off. Thank you very much, because I wasn't aware. All right, I think you guys should be seeing it now. All right, are we good to go?
No.
No, sir.
I cannot see your screen.
The screen share ended unexpectedly. You need to reboot the device if you cannot restart rebroadcasting the Zoom. All right, give me a second, guys. I'm going to jump out of the class and come back. Just give me a minute, okay? Are you guys seeing my screen now?
Yes, sir.
Yes, sir.
All right, I'm back.
Yes.
All right, so I do apologize for that. Let's get back into it then. So what you're looking at on screen in a second is going to pull up is a picture of a rectangle. And so the rectangle is a more elongated form. Some more elongated form of the square. All right, so with the rectangle now, the simple difference is that the rectangle has two long sides and two short sides, essentially. All right, and obviously then by logical reasoning, we'll know that this side is equal to, let me just use a black instead, this side. All right, so this side then, this side is equal to this side, and this side is equal to that side. Please pay attention to those indicators that I have. You will see these indicators in more advanced topics coming up. They are non-verbal communication to you. So sometimes we don't really tell you anything about the diagram, But the mere fact you see those indicators, it means that those indicators are telling you something. They are telling you that any side that contains the double stroke have the same length. Any side that has the single stroke has the same length. Now, unlike the square, where we don't need to differentiate between the length and width, with the rectangle, you have to differentiate between the length and the width. Now, it doesn't mean that the length always has to be the longest side, because you can have a rectangle that is vertical like that. Right? You can have a rectangle that is vertical like that. Right? You can have a rectangle like that, right? Where the length is actually shorter than the width. So we don't really have to say that the length is the long and the width is the short. Because you have people that say that. Right? They leave a math class thinking that the teacher said that. No. In this case now, because the rectangle is more like horizontal, in that shape, I'm going to call this one the length. I'm going to call this one the width. All right. And so width is usually indicated by the symbol W. And length is usually indicated by the symbol L. That's my L. I know someone don't really like how my L looking. It look like one E, sir. It's not an E, it's my L. So please appreciate my L. All right, so that's the width and that's the length. All right. So then we can derive a formula for this. We can say therefore then that area is equal to length times width. Or we can shorten it up and say area is equal to L times W. Let's put a couple boxes around this here. All right, good. All right, so that's your second formula. Again, the two formulas thus far will not be provided to you by CSEC. They consider them to be very basic, and you should know them from, I don't know when. We did learn them something from grade 4 or grade 5, I don't know. But the point is not, when we're learning it now. So area is equal to length times width. All right, and then attached to that, then you're going to have the perimeter. So perimeter is equal to, let's think about the perimeter then. If the meaning of perimeter that we discussed earlier represents the distance around, then we can just simply say that the perimeter must be L plus W plus W, because there's two width and there's two lengths, not true? We can simplify this then by saying L plus L is 2L and W plus W is 2W. So we can derive a more simplified version of the formula for What is this, Mr. Peart? I don't know what is it that I just draw while ago, guys. Don't laugh after me. So it is going to be 2L plus 2W. Let's see if we can get a box around this. Oh, nice. All right, that's fine. All right, lovely. So we have two more formulas that we have attached here. Area is equal to length times width, and perimeter is equal to 2L plus 2W. All right, and remember that when we ask for the area, ladies and gentlemen, once we ask for the area or we give you the area, essentially what we're asking for is the distance, or not the distance, but the measure of inside the middle here. When we ask you for the area, we're asking for how much of the surface, how much does inside this blue part here measures, how much does it measure? That's essentially what we're asking you when we say calculate the area of the shape. All right, that's essentially what we're asking you for. All right, so just like before, ladies and gentlemen, you can, of course, get the shape version. All right, you can get the shape version. And I can give you in a worded form. So let us just attach this question right here. All right, I'm going to go ahead then. I'm going to put some measurement on this. I'm going to call this 10. Why am I using this color? So I'm going to say this is going to be 10.4 centimeter. I'm going to put meters if I want to. I'm going to call this side 3.6 centimeter. All right. Again, it doesn't matter if the length and the width, if a student make a mistake and mix up the length and the width, multiplication is commutative. So what that means is that if I say 10.4 times 3.6, I'm going to get the same result as if I say 3.6 times 10.4. All right. So therefore then, from this question, we need to find two things. One, they're going to ask you to find the area. And two, they're going to ask you to find the perimeter. At this stage, that's what they're going to ask you. At this stage. When we get more advanced, they may not even ask you that. All right, so then let's go ahead then and set it up. So area then, to start this off, is equal to length multiplied by width. Quite a simple calculation. Here it's going to be 10.4 multiplied by 3.6. All right, so go ahead, guys, and process your calculation for me. Just verify that my answer that I have is 10. This is what 10.4. I'm so sorry. 10.4 multiplied by 3.6. I'm getting 37.44. Can someone confirm that?
Yes, sir.
Square centimeters. Thank you very much for the confirmation. All right, square centimeters because I'm looking for the area, right? And the calculation there, so it's finished. There's nothing more to do or to overthink. Nothing to overthink there. We can just proceed to finding the perimeter. Perimeter is going to be equal to 2 times L plus 2 times W. Okay, 2 times L plus 2 times W. All right, so that's going to be equal to 2 multiplied by 10.4 plus 2 multiplied by 3.6. And so that's going to be equal to 20.8 plus 7.2. When you work that out, you're going to get an answer of 28 centimeter. Can someone confirm that?
Yes, sir.
28 centimeter. Lovely. I know some of you guys don't really like to write stuff out, but that's how you get your marks. That's how you show the marker and the examiner that you have a comprehensive understanding of what is being asked and you know how to compute and put it on paper. So we have to get into the habit, right, of working stuff out, right? You use the calculator for verification, right? If you want to verify that the answer that you've gotten is correct. So at this stage here, I know that some person will just type all of that in and write down 28. I don't have a problem with that. Go ahead and do that, right? But if you can, and if you feel like you have the confidence, just take your time and just process. Just take time and write out the answer. Then that's more appreciated. But nothing wrong with the person that just types in 2 times 10.4 bracket plus 2 times 3.6 and write down 28. That person is equally correct as well. So it's not a big deal. All right. All right, lovely. All right, and just like before, ladies and gentlemen, you'll see me do this all the time in all my classes, no matter what it is. Every time I give you a question that goes forward, I will support you with a question that goes backward as well. So let's take this question down. Given that, this is the second example, guys, given that the area.
Sir, not seeing the Excuse screen. me, sir. I cannot see your screen.
Okay. All right, again, I'm going to have to exit the class and come back. Just a minute, please. All right, confirm if you can see my screen now.
Yes, sir.
Yes, sir.
Confirm if you can see my screen. Thank you. It's gonna happen. The device sometimes overheats and stuff, but we're back. Here we go. So given that the area of a rectangle is 104 centimeter squared. So given that the area of a rectangle is 104 centimeters squared and its length is and its length is 16.7 centimeter. Calculate, put a comma here, calculate, why is it in all caps? Calculate the, this word spelled wrong. Calculate the width of the rectangle. Calculate the width of the rectangle. And hence find the total perimeter. All right, so nice little question here that is in the worded form. Let's get it from in this text box here. There we go. So given that the area of a rectangle is 104 square centimeters and its length is 16.7, calculate the width of the rectangle and hence find the total perimeter. I'm almost certain that someone in here is looking at this question and be like, sir, you know, so I wouldn't even know where to start. That person's in here looking at this and be like, I literally don't know where to start and stuff here. If you ever find yourself doing a math problem and in your head you hear a voice say, I don't know where to start. Like, I'm so confused. The trick is always write down your formula. Everything is in the formula. The formula will tell you what to do. Especially if you can identify the keyword that will tell you which formula to write down. And here's the keyword that tells you which formula to write down. Area. The fact that you see the word area, the examiner is trying to get you to write down that the area.
Excuse me, sir. Someone in the chat is trying to say something.
Okay, I'm so sorry. Thank you very much. Let me check the chat. The monitor just went to sleep a while ago. My bad. All right, so someone in the chat, because I'm trying to say something, but I'm not sure if you hear me. No, I'm not hearing you, love. I'm not hearing you. So you might have, you can text it though, because maybe your microphone is not working. Oh, and hello, Finn. I'm call Finn, love. Lord Jesus. Mr. Finn, sorry. Just text it, man. Just text it. All right, so we start there by saying that the area of the rectangle is length times width. That's where you start, guys. You start by writing down your formula. And then all you have to know is just take the information in the question and put them in their respective position. The only information in the question is 104 square centimeters. We know, so when we see square centimeters, that is area. So you put the 104 right here. You don't need to attach the unit of measurement in the calculation. You just need to put the number there because we have calculate and then we write back the unit of measurement. So you have to put the 104 under the letter A because A represents the area and the area is 104. It continues to say, and its length is 16.7. You put 16.7 underneath the L. And then obviously the question is asking for the width. It says calculate the what? Width. So them ask you to calculate something, that means you don't know what it is. So you're going to write back the W here. And then simple now, ladies and gentlemen, all you do then is just to figure out what is the opposite of multiply. The opposite of multiplying is to divide. So that's going to be 104 divided by 16.7 divided by 16.7. And that should give us the answer for the width. So you just grab your calculator. Pardon me, just grab your calculator and you type in 104 divided by 16.7 and that produces the width. You can round off to 1 dp. You can just say that the width is equal to 6.2. So 6.2 is equal to the width. All right, and then that there is your final answer. All right, so that would be your final answer there. All right, so the formula, guys, is what? You see, and you throughout this whole topic, I'm going to say it so many times that you guys are going to be annoyed at me. Why sir keep saying that? Because that's essentially what removes the guesswork out of the mathematics. You guys are contemplating, do I multiply, do I add, do I subtract? When you can't figure it out, you're confused, then you start custom maths and say it hard. When in reality, all you have to do, guys, is to write down the formula that is associated with the question. And if, all right, Latisha, do take care, be safe, and I'll see you on Wednesday. All right, so all you have to do, guys, is just write down your formula and let the formula direct you. It's almost like I'm saying, okay, you want to drive, not true? You're scared to drive because you're scared to meet into an accident. But every driver or every instructor will tell you, put yourself around the steering. Go around the steering and then let the road will tell you, okay, turn left, turn right, slow down, speed up, look at that sign. By doing it constantly, you get used to the road codes and how to drive on the road. Same thing with math. Once you write, you see this thing right here, so let me put it in green. I don't think you guys will ever understand how powerful writing down this formula is going to be. In 2 months, you're going to look at yourself and I wonder, say, what or how in the world am I able to work these math problems that I once found so difficult? It wasn't difficult in the first place, guys. It all comes down to one thing. If you write down that formula that is associated with that question, then you'll find that the formula tells you what to do. It tells you if you must divide or multiply. All right? Now, another thing that I wanted to also highlight as well is the importance of this English transitional word. And this English transitional word is hence. Right? You see it all the time, but people just make it just fly over people's head. Right? Because it's English, they don't understand that the word hence is a powerful word in math. Why it's so powerful? Because hence in the English language means as a result of. As a result of what you just did. The information where you just get, the answer that you just got from the question prior to the one that you're doing now is what's going to use to help you to find the other answer. So if I go boom now and I go here and I draw a line here, and part off from the next calculation, I'm going to part off there. I can now use this answer right here to aid me in finding the what? Total perimeter. Because then I know that perimeter is equal to 2L plus 2W. And so I know that perimeter is equal to, I already know what the L was because in terms it was 16.7. So it's 2 times 16.7. And you see, because if you were not able to do part 1 of the question, then part 2 is impossible. Because then it's going to be 2 times the width. And this is where the hence comes in. 2 times the width is 2 times the answer you just find, which is 6.2. So therefore, perimeter is equal to 2 times 16, 16 and 16 is 32, 32, 7 and 7 is 14, 32, 33.4. Somebody confirm that, please. Someone confirm that. And this is 13.2.
Yes, sir.
This is 13.4, pardon me. And when we add both of these, guys, we should end up with 36.8. No, 46.8. 46.8 centimeter. All right. So if you understand, you're seeing the question in its full-fledged, right? Going forward, going backward. This is essentially what I'm training you guys to do, right? This is how I became very good at math. I was able to find the formula for how students are thinking. Students were always, what I find out is that you can give a student 10 of this question going that way, and they'll get it right. Oh, so it's just length times width. It's pretty easy. Just multiply the length times the width, and we get the answer. And then the instructor or the teacher or the examiner gives you a question that requires you to go backwards. Teacher never teach you that. But teachers aren't really supposed to teach you that, if you stop and think about it. Because you are supposed to be cognitively developed. But then again, we understand the culture of how we learn in Jamaica. Because in Jamaica, or even the Caribbean in general, not just Jamaica, in the Caribbean, right, we kind of learn math in a vacuum. So teacher teach it one way, and then give the question the reverse way, which is kind of unfair. You have to at least give the child a way to let them see it, and then give them the question, and then get it wrong, then they can say, okay, they are to be blamed. But you can't. Well, I don't think you can actually teach somebody one way and then give them the question the reverse and ask them to think about it. I think that's kind of crazy, but it is what it is. All right.
Sir,
Yes.
sorry.
Yes, go ahead.
Go on. The parameter in the second row here, where you have 2 times 16.7 plus 2.2. Yeah, this part here where you have 13.4, it should be 12.4.
Thank you so very much. I appreciate that. So therefore, the answer would have turned out to naturally be 45.8. Confirm?
Yes, sir, because I was wondering the same thing.
Man, don't be afraid to tell me. Yeah, man, don't be afraid to tell me that, sir, you made a mistake. I'm human, because I have 2 monitors in front of me, and plus I'm eating ice cream, so I'm distracted. I'm distracted. All right. So, ladies and gentlemen, essentially, this is an introduction to measurement. Notice I'll go slow. Me not try rush it. Me not try speed up the learning. I want you guys to get an understanding, right? So, up next, let us go back to, sorry. So I'm not trying to rush the process, guys. All right, let's go back up to our objectives all the way up here where we started. Question, somebody? Or no? All right, so essentially then, guys, we talked about a bit. Somebody wanted to speak, somebody's microphone is open. Okay. All right, so essentially, guys, what we talked about today was that somebody's microphone is open. Do you want to speak? You want to say something? Okay.
Hear me now, sir?
Yes, I'm hearing you there.
The part where you did the division, I don't get that part. It's kind of puzzling me.
Okay, that's weird. Show me, talk to me.
The 104?
Right here?
You divide it.
Yeah.
Yes.
Okay, so essentially what we're saying is that if we have a letter that we're looking for that is attached to a number by multiplication, the opposite of multiplication is division.
Okay.
So as long as you're multiplying and you want to isolate the letter, you just use the opposite of multiply. So if it was an add, you'd subtract. If it was a subtract, you'd add.
Okay.
Yeah.
All right, sir. Thank you.
You're welcome. All right, so essentially then, ladies and gentlemen, let's go back up to the initial objective of when we started the class. The aim was trying to complete 2 things, which I did, right? I wasn't planning to go to the circle anyways. So we would have completed what is a square, properties of a square, an example of how to find the area and perimeter of a square. Check. We have 2 examples of each. Rectangle is the same thing. We would have completed that as well. Looked at a question that finds the area of the rectangle, and in reverse, and we looked at the properties of a rectangle. So naturally then what comes up next is going to be, I think I'm going to do the triangle before I do the circle. I kind of want to get rid of all the shapes like this one and this one and this one before I get to the circle, because I don't want to go to the circle, then go to the triangle and then go back to the circle. So I just essentially want to get rid of the triangles and the trapezium and the parallelogram. Then I'll potentially leave the circle for last, because the circle is not really like the other shapes. It's more symmetrical and takes in a lot more stuff, like circumference and segment and sector and all that stuff. So subsequently, so I'm going to leave this one for last. All right, so essentially then, guys, when we come back in our next session, which is next week, Monday, when we come back to this topic, we're going to start off with talking about the different types of triangles, the properties of the triangles, what formulas associated with the triangles along with the trapezium, and then we continue from there. All right. All right, we're not ready to put together a worksheet for this because we haven't gone too far into it. So until then, we're gonna take our time. Yes. All right. Are there any questions before I get out of here?
No, sir.
No questions. Feel free to watch back the recording during. Sometimes I may post it in the week. I may post on weekend depending on how my schedule is. So whenever it pops up in the group, you're free to watch back the class. You can get access to this recording by clicking on the subscribe button that is pinned in. That the link is pinned in the group. You can get access to that. Somebody can send back the YouTube link in the group for the new students who joined today. so you can access it. And you can also watch the previous recordings of the previous class that we have taught so you don't feel left out. All right? With that said, have yourselves a productive, peaceful, and restful rest of evening. And I'll see you guys on Thursday. Okay?
Okay, sir. Have a good night.
You too, guys. Take care. Bye. Bye-bye, guys.
Bye-bye.
Bless up now. Bless up.